All right, we're gonna make a part together. Before we make a part, you need a part number. Luckily, I already made a part number, and that's the one I'm gonna use actually for this example. Hopefully you all had time to play around with it. If you haven't, here's a really quick tutorial on how to do stuff. First things first, let's sketch it out. Follow what I do exactly. I'm gonna choose the top plane. I'll hit OK. I'm gonna select a rectangle. I'll put it to the origin. I'll just throw it out there. I'll make this side 300. And it says, you're editing the first dimension of the sketch. Do you want to scale the entire sketch? I'll just say yes, why not? And I want to make this side also 300, so I could either do it by going like this and clicking 300, or I can click these two lines, so they're highlighted in orange, and I can say that they are equal by pressing Q. I just go up here and click it. When you do that, it automatically knows that this side to this side, because it's a rectangle, is going to be 300. Because this side and this side is 300, these two are the same. It's fully defined on the origin and how long all the lines are. On the picture, move my water all the way. On the picture, I also had a hole here. The hole is centered on the block. I'm actually going to make the hole a bit off center for this one. So let's put a hole right there. You can do it by clicking circle, define where the middle is, drag out to how big you want it to be. I'm going to click this circle's edge, and it gives me the option to make its diameter and choose its diameter. I'm going to choose 100 for the diameter. Enter. Click away. I can drag it around. Something that I really should have put in the tutorial video, last week's meeting, was how to make construction lines. So how do I define this guy? It's just kind of floating out here. One way I could do it, I could click it and select something to base it off of. Another way, which might be a better visually, if I click with a line, I'll just draw out here. I'll make this guy horizontal. There we go. I'll draw another one. From the center, snaps to horizontal. I'll click it there. Looks good to me. What you can do, if you click it, and this little bar pops up, or you can hit right click. This guy right here where it says convert to reference. So that means if you wanted to sketch something out and you didn't want that line to show up or that circle to show up because you're using it as a reference or a construction line, something to help you make your final sketch. When you click this, it makes it dotted and it hides it. So if I do the same for this guy, when I finish the sketch, it won't be there. But in here, it will be. So it gives me a little bit more freedom when you're doing more complex things to sketch things at different distances without those lines also being in the sketch. For this one, I'm going to make it 200. And this guy is going to be equal to this guy. Is there a way to reference a circle without reference lines? Yeah. So you just click the middle, and you could click either one of these guys or the axes. And by doing so, it gives a dimension. After we're done that, I'll finish my sketch. I'll extrude my sketch. I'll choose 300 as the height. So now we have a cube, perfect cube with a cylinder hole going through it. Hit OK. Now, what's next? I think I had to put a little chomp out of it. Let's do that. If I go sketch, I'll click the front plane. I'll choose this corner. If you go over here or here or here, when you click, you'll see that the origin is around, right? I'm going to choose it right here because that's where I want to put that bite out of the cube. Okay. I'll draw another rectangle on the origin. click out. This guy and this guy will be equal, and I'll make it 100 on all sides. And yeah, I'll click yes. Boom, finish. I'll extrude it. I'll drag it down. It's not subtracting, so I need to tell it to subtract. And I'll make it go down 100. If you type 100 in here and it shoots back up to the top instead of going down, what you can do is you can type in negative 100 and it just does the opposite direction. So I'll say 100, that'll put it in the right direction for me. I'll hit OK. And there we are. There's the block I wanted. Next things next, I was going to cover making an assembly out of it. So now that you got a part, your parts aren't going to be on their own. They're going to be with other people's. So you have to make an assembly or add it onto someone else's assembly file. Go to File, New, and under Modeling, you're going to choose Assembly instead of Model. Millimeter is the same. I'll just call it, that was good. All right. We are in. It asks you to add parts. I'm going to close this for now. And what we can do instead is if you go over to the top, we have a list of things you can touch on. A lot of them have very interesting things in that you'll never use. This one especially. You'll actually use quite a few of these. But assemblies is the one that you want. It's also available on the part file, but it doesn't work because you have an individual part and you can't make an assembly out of itself. You have to make an assembly file first. Even though the file ends in .part for the model and the assembly, a little confusing, but you want to make the assembly, then click over to the assemblies at the top. You'll want to add your components. So I just had, it'll ask you what ones you want to click on, and you can search it through here. This is completely irrelevant. What you want to do is click this file folder, open it. I'll go to my downloads here. What did I call it again? I call it OG2469. There it is. Okay. And then you can choose how many you want. I'll say 3. How about? And then for the location, if I click this, it allows me to kind of drag and drop them around. I'll just stick them right there or not. Oh, quick learning exercise. See this? So these look like they're solid bodies, but they're not. When I drag them out of the camera frame, it breaks the illusion. These are surface models. How lovely is that? It's saving resources. Anyway, I'll click it around. You can drag it how you like. If you want to be centered, you could make these all 0, 0 if you really cared about. And I'll snap them to the center. But anyhow, I'll hit OK. I got my 3 little dudes. Look at them go. But they're not where I want them to be. I want to assemble them. They're just kind of sat on a table right now, if you want to think of it that way. So what I can do is I can move them. If I click one of them, specify orientation, this handy thing shows up. It allows me to drag it in any which direction. As well, if I grab this dot, I can just freely move it. And then these dots allow me to rotate it on the 3 different planes. So if you want to try and adjust it before you assemble things, that's how you do it. If I want to stack these guys on top of each other, I could do my best. I'm going to move it up as well. So instead of hitting OK and then closing the dialog box, I'll just hit Apply. I'll keep it open. And I'll just select the next guy. And I'll specify it as well. And then it goes out of camera, so I'll hit Control F to bring it back. I'll drag it up. And I'll hit OK. And so now the 3 of them are stacked. But remember, this is isometric view, or in CAD. And so despite them looking like they're all stacked on top of each other from this angle, the second I rotate it, it just blows apart. So keep that in mind. Whenever you're moving things around and you click on the guy, it does give you the coordinates. You can see this one's 1,500 millimeters away on the x-axis and 1,200 away. If I just make that 0, 0, and I just bring it down, that is more what we're looking for. And you can see that it actually intersects the part that was there earlier. So I know that that's a lot closer. And similarly, it looks like it's pretty close to the other guy. I'll say it's right there. Again, move. If I click it, it's these 3 dots on the planes you can think of between these axes. So if I grab it, I can spin it around, and all of them work the same. So moving them is great and all, but there's nothing tying the relations between all these different pieces. So what I need to do is constrain them. Like our sketches, you can't just have non-constrained things where things will explode or blow apart in your CAD. And your computer won't be happy and you won't be happy. So what we do is we go to Assembly Constraints. Opening it up, it gives us a bunch of options. I'm going to close that one for now. But I'll just go through them first. So this guy is Touch Align. Touch Align says, I have a plane and a plane. And if I select plane 1, select plane 2, it'll just snap them together. I still have freedom in X and Y on that plane, but I can't go off and I can't go into it. I'm stuck to it, I'm touching it. Concentric, I have 2, these are rectangular, but I have 2 circles, and I say join them together. If I put a bolt through this, that hole is the same all the way through, despite it being 2 parts. I have the ability to rotate. I don't have the ability to leave the face. It connects the 2 faces. So if I go ahead and do an example of both of those, face align. I'm going to connect this guy to this guy. And it gives me a little constraint guy that shows up. If I apply it, and I just go from this angle, you can see that they're perfectly straight. It's not on the plane, but if I tried to, it's not touching, but if I tried to move them around, if I move this guy, I can move it side to side, I can move it forward and back, but I cannot move it up and down without moving the whole thing because they are tied together. Discard changes. If I make the holes concentric, so if I touch that one and that one, it sticks them together. And if I try to move it, you'll see it allows me to rotate it. Notice how the part that I'm moving, this guy, will rotate, and because it's linked to the other one, this one won't rotate, but because it has constraints where it's touching each other, it will react accordingly. It's so fun. If I tried to rotate it this way, it just, the holes inside are still aligned. I can look at it like that and see that this is just one straight hole going all the way through. So doing this just keeps the faces together. And if you made a constraint and you're like, oops, I made a mistake, you can go into this right here under constraints, and it will give you sorry, that's not constraints, I'm too far away from the screen. If you go over here to the assembly navigator and hit constraints, it shows you that you have a touch align and a concentric align. If I want to get rid of them, I can click them and delete them. And now there's nothing tying them together. If I move them now, there's nothing to say that this part is connected to the other one, and so it just drags apart. What other constraints do we have? Oop, not that guy. We have distance. So distance says I have a thing here and a thing here, and I don't want to constrain them by touching. I want them to know that they need to be some number apart from each other. That's what distance says. Really straightforward. Whatever faces you select won't get any closer than your distance tells them to be. Fixed is really helpful. Fixed says, take person A and lock them down. They are no longer allowed to move. And everything else that you start rotating, so remember how I concentrically constrained this guy and this guy, I hit apply. If I fix this bottom one, instead of it rotating and kind of dragging that bottom one with it, what it will, oops, there you go. What it will do is it will leave the bottom one where it is and only the top one will rotate around. Super handy if you don't want your constraints to be reactionary. So this guy stays where he is, and this one can rotate freely. Oops, okay, sure. Other constraints. Parallel. I think you guys get the gist of what parallel does. Makes things parallel, perpendicular. How original, it's kind of the same as parallel, but the other way. Align lock is like concentric, but instead of allowing twist, it allows for sliding movements only. So concentric movement, you can think a lot like a gear spinning around a shaft. The gear should not be moving side to side as it's spinning. So you'd use concentric, where it's locked and it spins. Axial, if you have a hydraulic or something where it's pushing, coming out like that, and it's sliding along a shaft, and you don't want rotation for whatever reason. Let's say you had like a punch and you're like lining it up with something else, you'd use a line lock so that it just slides in that direction. So I'll use that example. I'll get rid of my concentric constraint, and I'll make a line lock. It selects this guy, and I can grab it through the part. That guy, and if I move it, instead of rotating, it won't let me rotate it because it's fixed. If I got rid of the fixed one as well and did this, so now if I rotate it, it'll rotate both of them. I can move them, of course, as usual, but instead of the top piece rotating around that center shaft, now it's only allowed to do this motion. How fun. Fit. I've never used this before. If you need to use it, I'm sure you'll find out what it does. Bond, that's handy. So I'm trying to think of an example in real life. We had the chassis jig, and the chassis sat on this big big wooden board with these like arms poking out that held in place. In order to put the A-arm nodes on, or like these little square pieces, which are really weird angles, we 3D printed a ton of these little adapters that would fit onto the end of the wood pieces and then fit inside the metal tube so that it perfectly lined up. Yeah?
I think you should show it.
I think I should. I'm not sure where I would.
It's on Slack.
Is it on Slack? Sure. It's not the one that I'm thinking of, but it will do. Here we go. So I had a big wood board, and we cut a bunch of holes into it. And an example, that one in the middle, which had the tracks, that was a piece which had feet that would stick into the board, and the tubes would lock onto it. And so the chassis was kind of suspended on this like wooden arm thing. And I don't think this one had it. Let's see if the other ones did. Okay. No, but we had 3D printed pieces that would go over these pieces and then inside a tube to fit on the chassis. And an example of using the bonded feature, really long-winded way of saying, to use the bonded feature, you could have your wooden part, the second part, put them together, bond them, that way they're one part under CAD. Is my take on that. I've never used it before. To be honest, I don't think I've used these two especially. I've definitely used center. If you have like a big assembly and you want to line it up to something, you can use center to line up pieces. It's kind of hard to do with just these guys. If I had, from this angle, if this guy was down here, right there, and I wanted to line up a guy in the middle, I'd use the center align. So I click the first one, and I click the two that I want to be centered on, and then I would just kind of line it up. Wave linking is too difficult, so I'm going to open up an example of wave linking. Arrow goosenecks. There you go. Oh, okay, not that one. There's another one. So this is a part, or an assembly, I should say. These were the upper wing mounting solutions, the big arms that kind of come out. And this was the front wing mounts. And for the water jet, we had a sheet of aluminum this big, and we just plot it down. The water jet would cut them out. So that's what that is. I have another file somewhere. I'll find it this way. I'm going to brute force it. I'm going to get the entire car. I'm going to find it. All right. It's not chassis. It's not kinematics. It's not electrical. It's aero. And of aero, it's not any of these. It's up here. It's these guys. What do you wonder? It doesn't say. It's not the side pods. It's not rear panels. It's not the front wing. Well, no, maybe I want us for the front wing. It's not the rear wing. Okay. Here's an example of wavelength geometry. So in order to make references to your components where you're basing off their coordinates on the grand scheme of a whole assembly, instead of saying, I want to import the entire chassis, you can wave geometry link, which kind of takes like a fake one, and it brings in the things that you need. So this right here, this is the like 000 datum for the chassis, and these are some tubes that help base off the center line, and they are wave-linked as well as whatever this guy is. And they are a part of the chassis, so they're wavelength geometry, and when they do that, it doesn't take the whole part, it takes only features of the part that you want to reference to. Is probably the best way to say it. It takes features of a part that you want to reference, not the entire part itself. The file I was trying to find, it was the goosenecks. Oh, this is the FEA version, where it was wave geometry linked to the hood to see how it would line up with the rest of the hood. So it just took like the outer face of like the part of the hood where it would be in contact, and then when people align it and stuff, it adjusts. It's quite smart actually, and you can find it under here. That's it for tonight. Thank you guys.